Hey there, everyone. Ryan Schul at Straight Data Science Channel. Let me take you through a couple concepts that I stumbled upon a short time ago. I think this is pretty interesting, and I think you will appreciate it too. There's something called a loss function and a cost function. So at its core, basically, a loss function is a mathematical tool or construct that we can use to measure how far a model's predictions are away from the actual outcome that we would achieve in reality, right? So think of it as a coach giving feedback to a player, and how close are you to where you need to be? And if you deviate a little bit, like how do we get back on track, that kind of thing, right? So a common point of confusion is the difference between the loss function and the cost function. The loss function is really evaluating the error for a single data point, okay? The cost function is looking at everything comprehensively, right? So think of it like this. Loss function basically measures the error for a single data point, right? And the cost function is the average of all the errors across the entire data points in your entire data set. So let me import some data here. This is a classical or canonical mtcars data set. I have a couple items on my channel that I speak specifically to this. It's basically information about cars, right? So we have the car name that is in the first column there, row name, and then we have the miles per gallon, the number of cylinders, the displacement of the engine, horsepower, and so on and so forth, okay? So this is just a good example just to illustrate the point here. I think this is going to make sense using this data set. So basically, I'm going to look at two sides of the coin here. We have regression and classification. I have several videos on my channel about both these topics, right? Regression is looking at numerical data points, right? Numerical representations of the data, and a classifier is looking at label data, or it could be binary data. So true, false, yes, no, on, off, things like that. Or it could be label data where we're looking at different types of fruit. Could be a banana, an apple, an orange, grapes, pineapple, something like that. That would be a classifier. So you show a classifier an image, and it will identify it as a certain type of fruit. When you dump data into a regressor, it's going to learn the patterns of the data, and it's going to make a prediction about some type of numerical data point here. So the independent variable in this case is going to be horsepower. The dependent variable is miles per gallon. So this should make sense, right? The more the horsepower of the car, probably the less miles per gallon, unless the engineering team that built the car is just phenomenal. Typically, as horsepower increases, miles per gallon decreases, right? So that's pretty normal. I think that's pretty much common sense. So let me run this cell right here, and we'll see what we get. I'm looking at the Random Forest Regressor, fitting the model and making predictions here, and looking at the R squared and the MSE, that's the mean square error. So this is the error away from the ideal predictions, right? So if the model had no error, it would be 100% accurate. And if it has a high R score, it's going to have a lower error, and it's going to make better predictions. So in this case, the R squared score is 0.8924. So 89% of the time, the model is making accurate predictions. 11% of the time, it's not making accurate predictions. And there's ways to improve that R score. This video is not about that, right? We're focusing on loss functions and cost functions. So I'm going to go ahead and print out the cost function right here. Let me see. I need to get glasses soon. This is getting kind of hard to see this stuff. Okay, there's my R squared. Yes, okay, so I got it. So here is the loss function. Remember, this is all the individual rows of losses, right? And the cost function is the average of all the losses for the whole model, right? So I'm printing out the MSE y test minus y predicted. That's how I'm getting my loss function. And you can see the error for each one of these cars, right? Because we're looking at rows of errors, individual errors. So this is the lowest error. This is the best, the Pontiac Firebird. This is the highest loss function right here. And that's okay. There's ways that we could probably trim that a little bit and make that a little bit more accurate. But overall, the model is performing pretty well, 0.89 R squared. So these are all the loss functions for every single row, which a row is comprised of car. And the overall average for the entire model is the cost function, and that is 4.30, right? So the Fiat really had the worst predictive outcome right here, and the Pontiac Firebird had the best predictive outcome. And again, we're looking at horsepower as the independent variable, and miles per gallon as the dependent. So as horsepower increases, miles per gallon decreases, almost guaranteed. There might be one exception somewhere, but I doubt it. So now let's look at the other side, classification. So I'm going to use a Random Forest Classifier before I use a Random Forest Regressor. If you look close here at the code, this is a Random Forest Regressor. It's very interesting how with Random Forest they can do both of these, right? They can do classification and regression. It's the same with the XG Boost. They have a classifier and a regressor. So these come in very handy and they tend to perform pretty well in most situations, okay? And I'm going to share all this code with you guys, by the way. So you don't have to sit there with your notebook and try to make notes and understand all the details and the nuances of everything that's going on here. I'm going to share the code with you so you can copy and paste it into your own Jupyter notebook and run it there, okay? So, so that's the setup. And in this case, I'm going to create a label, okay? Because all of this data is numeric. So we're looking at miles per gallon, cylinders, displacement, horsepower. These are all numbers, right? I want to create a label and say, is this car efficient based on the miles per gallon? If it's less than 20, it's efficient. Actually, now, wait a minute. This, I think, is I'm looking at the wrong side. If it's greater than 20, it's efficient. Yeah. I don't know why it must have had a lapse of reasoning there. So if miles per gallon is greater than 20, it's efficient. If it's less than 20, then it's not efficient. Okay, so hopefully that makes sense. Okay, lost my train of thought there. I don't know why I put it at less than. So we created a new column, and although it looks like numbers, it's actually a binary feature over here. So ones and zeros. Greater than 20 miles per gallon, this is an efficient car. Less than 20, it's not efficient. So that's what I did there, and I'm using the weight of the car as the independent variable, and the target variable is going to be efficient. That's the column that I just created, or the feature that I just created. Okay, so let's go down here, and again, we're doing all the same things as before. Looking at this from the perspective of a classifier now, right? And we're looking at the loss function compared to the cost function. So again, the loss function is the deviation of how much the final predictive capabilities of this model is off from the actual value where it should be, right? So here you can see the loss functions are pretty small, and we get one for every single row. Remember, loss function looks at the details or the nuances of the data, right? So you get a basically a loss function for every single row, and the cost function is the loss for the entire data set comprehensively, right? So the average loss is 0.630. So again, the model is pretty accurate. It's making pretty decent predictions here, and the outcome is satisfactory, right? So there was actually one, okay, so this had zero loss, so that was making a perfect prediction right there for the Hornet Sportabout, but these others were off by a tad. Oh, hey, we had two that were perfect, right? The Datsun 710 and the Hornet, and the least accurate prediction, I guess, was this one right here, the Mazda RX-4, but overall, it's only 0.06, so relatively low for the average of the entire data set. So these models, the Random Forest Regressor and Random Forest Classifier, are performing pretty well, and we're pretty satisfied with the outcome. Okay, so again, loss function measures the error for a single data point and quantifies how well the model is able to make predictions that match the actual value that is embedded in the data. And the cost function aggregates everything over the entire data set so we can see the average of everything comprehensively, right? And it's a metric that basically helps the algorithm to become more optimized and minimizes any error during the model's training. So that's pretty much it. I thought the concept was kind of interesting, and I wanted to present my findings to you guys. So that's it. I'm going to wrap it up right here, and I will see you in the next video. Take care for now. Talk to you soon. Bye.